Okay, welcome to the day 5 video. It's actually lesson 4, but it's the 5th day of our unit so far. Today we're going to simplify more radical expressions and divide radical expressions. And the question today in your notes is, how will I divide radical expressions? So far I've added, subtracted, multiplied, and now I will divide. So again, if I ask you to put something in simplest radical form, there should be no perfect squares in the radicand, which means if I have the square root of 4, you will get a point off, -1, because you can actually simplify this further and take out the 2's. The square root of 4 is 2. There should be no radicals in the denominator, and now we'll finally tell you how to deal with this problem. 1 divided by the square root of 2. If I know 1 divided by 4, I understand what that means. If I have a bar that is 1 unit long and I want 1/4 of it, I can cut it in half like this and then fill in 1. But the problem is, I don't know how to divide by the square root of 2. I don't know how long the square root of 2 is off the top of my head. I'm not quite sure how to divide something into the square root of 2 pieces. So we'll talk to you about how to do that. There should be no fractions or decimals underneath the square root, so I should not have the square root of 2 over 4. And we'll talk about how to deal with that on the next few slides. So, much like I did in the video for lesson 3, I'm going to prove why this property is true. If I let a be 4 and b be 49, now I take the square root of a divided by the square root of b. Well, if a is 4, I have the square root of 4 divided by the square root of 49. You should know what the square root of 4 is at the top of your head. It's a perfect square, so it's going to be 2. The square root of 49 is 7. So 2 out of 7 will be my answer. Now, if I have the square root of 4 divided by 49, that's a little bit harder to answer. Okay, that's going to be a little bit tougher to figure out. But if I try to factor out the 4 and the 49 now, this would be the same thing as 2 times 2 over 7 times 7. They're both perfect squares. Now, because I'm multiplying, I could split those up. 2 over 7 times 2 over 7. And remember, the square root is asking, oops, should be a 7 there, not a 2. So it's asking, if I multiply something by itself twice, I should be able to pull it out of this radical. So of course, you get the same fraction, 2 over 7, as its answer. Now again, this is true for all these examples. If I have the square root of 36, a is 36 and b is 4, of course the square root of 36 is going to be 6, the square root of 4 is 2, it should be 3. Now if I do it all in one radical here, 36 over 4, I can divide 36 by 4. How many times does 4 go into 36? Well, it should be 9. The square root of 9 is 3, so I get the same answer as I did before. And finally, in the last particular example, if I have the square root of 36 divided by the square root of 25, I should get 6 over 5. Now, if I do it all in one radical, like so, 36 divided by 25, you'll see that I have the same situation I did in number 1, where if I factor out 6 times 6, and 5 times 5, I can pull out the same fraction twice. It should be 6 over 5. So we have stumbled upon a rule. The square root of a over b is equal to the square root of the fraction a over b. Now remember, if I multiply by the same radical, I get the square root of 3 times 3. It should be the square root of 9, which is just 3. We know all this. This isn't anything new. I don't need to go through this entire slide that you figure out that it doesn't matter what you're multiplying. If you multiply with the same radicand and the same index, if you already have enough, you should get the square root of 25, which is 5. This would go down all the way. I'm not going to go through all of them. Just know in general, the square root of a times the square root of a would just equal the square root of a squared, which is just a. Now you need to remember this for the next part. If I have 1 over that square root of 2 that I was talking about earlier, if I don't know what that means, it's a little bit easier if I can rationalize the denominator, which means to get the square roots out of the denominator, or get the radicals out of the denominator. It might not be a square root, it might be a cube root, but let's take a look here. 1 over the square root of 2. If I don't want there to be a square root of 2 in there anymore, I need to fill it up so I have that square root of 2 times itself. What this will do then, just like you saw in the last slide, is it's going to combine the 2 and the 2 underneath the same radical. Now if I multiply the bottom of a fraction by something, in order to make it equal, I have to multiply the top of the fraction by the same thing. So I have 1 times the square root of 2 because, of course, it's not inside the radical. So now I have the square root of 2 divided by, if I pull this out, 2. Now again, I might not know what the square root of 2 is, but I definitely know how to divide whatever that is by 2, if I can get an approximation. If I have 1 over the square root of a, I need to have 2 a's underneath there, but so far I only have 1. So I'm going to multiply by the square root of a on the top and on the bottom. I have 1 times the square root of a over the square root of a times a, because they have the same index. And I have the square root of a over a. This is called rationalizing the denominator, making it a rational number on the bottom side, so we make a fraction that is making sense. So for example, I have a radical in the denominator. That's a no-no. I don't want that to happen. So I want to get rid of that radical in the denominator. It's a square root, so I need 2 5's underneath there. So I need another 5 to be under there. So I multiply the numerator and the denominator by the square root of 5. 2 times the square root of 5. The square root of 5 times the square root of 5 would just be 5. And that would be my answer. I'm not showing all my steps because I don't have time or space to do that. You should know by now that if I multiply the 5 by 5, I get the square root of 5 times 5. I can pull it out. The radical goes away. Over here, I have 3 over the square root of 3. I multiply. I need another 3 underneath that radical to break it out of the square root. And notice the top numbers don't combine because one has a radical and one does not. But now I have 3 divided by 3. I can simplify those numbers on the outside by dividing them by 3. And I get 1. It should just be the square root of 3 over 1. Over here, I need to get another 8 out of there. I want to get rid of that radical, square root of 8. Okay, so I have 2 times the square root of 8 over 8. Now there's 2 things I could do to simplify. The first thing I could do is simplify that fraction. Divide by 2. And divide this by 2. I'm going to get 1 over the square root of 8 over 4. But the square root of 8 is actually 2 times 2 times 2. That's 8. So I can pull out a group here. I'm actually going to get 2 square roots of 2 over 4, which is actually square root of 2 over 2. Now, there's another way you could have done this to maybe make it a little bit easier for you. If I started again with the same thing, 2 over the square root of 8, and let's say I simplified the square root of 8 first, 4 times 2, and now I have 2 over 2 square roots of 2. That divides out, and I have 1 over the square root of 2. And again, I want to get rid of that square root of 2 in the denominator. Now I'll get the same answer if I rationalize this way instead. Square root of 2 over 2. Same answer for the same problem, just the different methods of doing it. If I have a fraction like this, your first goal is to try to simplify the fraction if you can. If not, just go ahead and split it up into 2 different radicals. But does 4 to 24 reduce? You should be saying yes, 1 over 6. Then it turns into the square root of 1 over the square root of 6 by the properties of radicals. You can divide and create separate radicals there. The square root of 1 is just 1 over the square root of 6 does not simplify, but can't have that radical in the denominator. So I need to multiply by the square root of 6 on the top and the square root of 6 on the bottom. And so my answer then would be the square root of 6 over a 6. Can 3 out of 20 simplify? Nope, they have no common factors. So I have to start by splitting up the numerator and the denominator into their own radicals. Okay. I could choose to simplify this radical first if I want to. I'm just going to multiply by the square root of 20. I'm just going to go ahead and do that, and I'll simplify later. This is just my preferred way to do it. You can do it whichever way you'd like. So now I have the square root of 3 times the square root of 20. They're both underneath the radical, so I can get the square root of 60 over 20. So the 3 and the 20 combined this time because they both had a radical. Now I need to simplify the square root of 60. The square root of 60 is actually 3 times 20. 20 can break down into 4 times 5. Sorry, I forgot the 3. Try that again. 3 times 4 times 5 over 20. I could pull out that 4. That 4 is 2 times 2. It's 2 times 2. So is there going to be 2 on the outside? The square root of 3 times 5, 15 over 20. Reduce the fraction. It should be the square root of 15 over 10. I divided these by 2. They're both on the outside. Now you can only divide and simplify the fraction of the things that are on the outside. You cannot do that with the radical numbers. Let's look at this one. These radicals can simplify right away. 12 is going to be 4 times 3. The square root of 4 is 2, so it's going to be 2 times the square root of 3 divided by, now this is going to be 25 times 5, so I can pull out 2 5s there. So 5 square roots of 5. Now the problem is, not that these are not simplified enough, and these are simplified because 2 and 5 don't have any common factors, but this square root of 5 in the bottom is what the problem is. So I need to rationalize the denominator by multiplying by the square root of 5, and that will help solve some of my problems here. So it turns into then 2 times the square root of 15 over 5 times the square root of 5 times the square root of 5 would be the square root of 5 times 5. So the 5s will come out. I have 2 square roots of 15 over 25. Can that simplify? No, it cannot. I am done. Over here, try to simplify the radicals again first. This is 9 times 3. So it's going to be the square root 3 times the square root of 3. On the denominator, this is going to be 4 times 5. So it's going to be 2 times the square root of 5. It's the exact same thing. Isn't that interesting? Okay, maybe you're not thinking it's interesting. I think it's interesting. You get the exact same answer. So I'm not going to go through the process again just to save time in the video. All right, so again, to recap, if I have the square root of something, like 48, my goal is to simplify the radical by factoring into perfect squares. Now 48, I don't think any perfect squares go in there, do they? Well, actually, yeah, 4 does. 4 times what? 4 times 12. And I actually missed a bigger one. 16 should go in there because it's going to be 4 times 4 times 3. Pull up the 4s. I have 4 square roots of 3. And that was the first thing we did. Then the second lesson we had is what happens if I have things that are added together, like 2 times the square root of 3 plus 6 times the square root of 3. Well, these are like terms because they have the same, oops, I'm not going to use that color. We have the same radicand, and I have the same index, which happens to be 2. And since they are like terms, I can add the coefficients together, 2 and 6, to get 8 square roots of 3. Same thing works when I'm subtracting. However, if I have 3 square roots of 5 plus 2 square roots of 20, I cannot add those together yet because they do not have the same radicand. But I may be able to factor that radicand so that it does. Square root of 5 cannot simplify, so it's going to stay the same the entire way down. But this 4 will come out as a 2. 2 times 2. This is 2 times 2, and that's what I'm pulling out actually is the 2's. If there's a 2 already there though, 3 square roots of 5 plus 4 square roots of 5. How many square roots of 5 do I have? 7 square roots of 5. And the last thing we learned to do before this video is to multiply them. So if I had 2 times the square root of 2 multiplied by 1 plus the square root of 7, I can't combine these inside the parentheses because they're not like terms. So I must distribute the 2 square roots of 2 to both terms. 2 square roots of 2, 2 square roots of 2, and I'm going to put all the other stuff that was in there before. So multiplied by 1 plus multiplied by the square root of 7. Okay. Now, obviously, on the left side, it's not going to change much. 2 square roots of 2 plus 2 times the square root of 14. And I can't combine these two because they don't have the same radicand I'm adding, so we're good to go. If I multiply two things with the same index and the same, well, actually, it doesn't even have to be the same radicand, times 4 times the square root of 3. We multiply the things on the outside, I get 8, square root of 21 on the inside. All right, that's just a summary of all the things we've learned so far. In this video, we did dividing. Make sure that you ask me questions if you have them. Have a good evening.